Here we're going to be looking at graphing polynomial functions, and how does the value of n affect the n behavior of f of x is equal to x to the n. Let's look at the first example. As a reminder, if I have to graph f of x is equal to x squared minus 5x, then I can factor out the x they have in common, giving me f of x is equal to 5 times the difference of x and 5. Using my zero product rule, I find that x is both 0 and 5. This means that I have two answers, two areas where that polynomial could cross the x-axis. Here we see that there are two answers and it is raised to a power of 2. This may be coincidental, but this might be something to take notice of. Our next example will be raised to a much higher power. Here we have f of x is x to the fourth plus 3 squared minus 5x squared. So I'm going to start by putting this into standard form. When I factor out what they have in common, I'm going to get f of x is equal to x squared times the difference of x squared minus 5 plus 9. I can see two x's that occur in this equation, which means I have, using the zero product property, that the x squared is 0, and the x squared minus 5 will give me 2 points of a plus or minus radical 5. So a ballpark idea of what this is going to look like is appearing on the graph. I see that it turns more than one time. It turns 3 times, but I have a fourth power. But I only see that I have 3 answers. So what I may be seeing is a correlation between that exponent and a number of answers. Where in the first example there was 2 answers and it was a 2 power, there's 3 answers here and it's a 4 power. So it seems that the highest power is the most answers that I can have. In the third example, we have f of x is equal to x cubed plus x squared minus 5x. We can factor out the x they have in common to get f of x is equal to x times x squared plus x minus 5. We could also factor within that to get that x times x plus 1 minus 5. This will give me some 0 points using the zero product rule of 0, 0, and negative 1. And now I'm leaving this with you to see if you can solve this and to see how it goes all on your own. If you feel a little unsure, a good way to test it would be using the x and y table, where you'll fill in all of the x values from a very low value like negative 8 and work one at a time all the way up to positive 8 and see how that works. If this video has been helpful, please like or share, and if you have any questions or comments, they go below.